All right, so today we're going to look at section 4.4, which is on scatter plots. And basically a line of fit is when you have a bunch of dots and it looks like they make a pattern, you try to draw a line right through the middle of the dots. Okay, so at the top of your notes, okay, you have a blank that says a blank is a graph that shows a relationship between two data sets. You want to fill in scatter plot. Okay, so in that first blank at the top of your notes, fill in scatter plot. Okay, Mr. Roy and I put that in bold right there. Okay, two dashes right below where it says scatter plot. Okay, the first thing is that you're going to be given like a table, okay, or a set of data. Basically, that table that they give you is like ordered pairs. Okay, when you make a scatter plot, you're basically graphing a bunch of points. Okay, so you're graphing a data set as an ordered pair. Okay, you need an x value and you need a y value. Okay, what I'm going to do is I'm just going to go to example 4 for a second, just so you can see an example of a data set. Okay, but I'm going to come right back to this. Okay, so this is what a data set looks like. Right here, this is a data set. Okay? They give you an x value, which in this case happens to be a week. And they give you a y value, which is sales. Okay, so this has to do with selling something, DVDs. Okay, so selling DVDs. Right, so x value, y value. Okay. Any question on that? That's a data set. All right. Okay, and the biggest thing that we use a scatter plot for is to try to find a trend or some kind of pattern in the data. All right, if I go back to example 4 and I bring that table back up, that's not a big table. Okay, I think maybe there were, maybe nine weeks in the table, 10 weeks, not that much. But let's say you had a table of data that had thousands of columns in it. That's just so many numbers that it's really hard to see if you have a pattern. Okay? So a lot of times when you have that much data, it's so much easier to look at a picture if you're trying to find a pattern than to look at a table with a bunch of numbers. Okay, so do you think every scatter plot is going to always have a pattern? No. You might make a scatter plot, and it might just look like the dots don't have any pattern. Okay? Or if they do make a pattern, we're going to talk about 2 special patterns you can have. All right, so let's look at that one. Okay, we're going to do something with this in example 1, but if you guys just take a look at this, okay, and I think it's already on your sheet, does it look like there's any pattern here? What do you think? If you look at those dots, does it look like?
We're going up like this.
Yeah, I would say it doesn't look like this, right? It doesn't just look like you have a bunch of dots without any pattern at all. They kind of make a pattern. Can anybody describe what the pattern looks like? Yeah, it looks like they're kind of going up and to the right a little bit. What else do you notice about this scatter plot? And maybe how it's set up? Because there's a couple things you always want to do whenever you make a scatter plot, and this scatter plot does it. What do you think you have to do? You have to what? Okay, you have to put in some numbers. So, like if you had something like, let's see if I have an example, like this. Okay? If you're going to set up a scatter plot here, first you got to put your points, right? You got to do that. But what else do you think you have to put on this besides points? See, that's the data, but to try to make this so somebody who's looking at it would understand it. Yeah, you have to put a title. Okay? Every scatter plot that we look at is going to have a title. So that way you know what you're looking at a scatter plot of. What else do you need to do besides the title? Look at this scatter plot.
Put in what you are trying to measure, like they're trying to measure sugar in grams and then with calories too.
Yeah, you have to put down what your x-axis is. So in that case, it's grams of sugar. And on the y-axis, you're measuring calories. Okay, so anytime you make a scatter plot, you have to put those three labels. The x, the y, and a title. Okay? How about these symbols? Let me make them a little bigger. If you can't see them. Anybody know what that symbol is right there? Kind of goes like this.
It shows that's where the zero is.
So it's not showing where the 0 is. This symbol means something, and then they have another one going up as well. It means the same thing. Yep.
It's showing there's not like an equal amount of it going up. It's the rapid jump.
Yeah, exactly. It's showing you skipped. See how they're going by 4s? 46, 50, 54. They're always going by 4s, except from here to here. They skipped. They jumped a bunch of stuff. So when you do a scatter plot, if you want to skip a bunch of numbers at the beginning, that's okay. Just make sure you put this symbol in, and that shows that you skipped everything between 0 and, in this case, 46. Okay? Same thing on the y-axis. They skipped everything from 0 to 240. But then after 240, what did they go by? Yeah, they went by 10s. Okay, so you always have to go by the same thing, but they just skipped a bunch of numbers at the beginning. All right, so let's take a look at the scatter plot and see if we can answer a few questions. All right, so here's a little description. It says the scatter plot shows the grams of sugar. Just make it a little smaller so we can see it. Scatter plot shows the amount of grams of sugar and the number of calories, okay, in 10 different smoothies. So maybe it's just 10 different stores that make smoothies. Okay, first thing I want to try to figure out, and I think you guys already have the question written down. How many calories are in the smoothie that contains 56 grams of sugar? How many calories are in the smoothie that has exactly 56 grams of sugar? Right? Yeah, Ashley?
270.
Yeah, how did you figure that out?
I don't know what a sugar is, and 56 is between 54 and 58, and it's leaving the dot right there, so I just went over and 270.
Yeah, so what you can do is you can basically draw a line, okay, right up there. That's 56. And then from that point, just kind of trace over, let's adjust my line a little bit, but trace over to the side. Okay, so you can just kind of go like that. And that shows you it's 270 calories. Okay, so on your guided notes under part A, put 270 calories. Yes? Oh, the answer for part B? Okay, does anyone have any questions on part A? Okay, when Mr. Roy and I set this up on the test, we're going to make it clear, just like this one is. Okay? We wouldn't give you a dot, like that. Because now you're trying to figure out, well, is that 277 maybe, 278? It's hard to tell. We're going to give you ones that are nice numbers. All right, so Antonio, you were going to say something about part B. Okay, so go ahead. Tell me, how can I figure this out?
You go in 320.
Okay, so we go up to 320.
You just go as far as you can so you hit a point.
Yeah, go, okay, we just hit a point.
That's fine.
And then what?
I look down and see that it's 70.
Yeah, and now from that point, just draw a line or just look straight down, and you can see that if the smoothie has 320 calories, it's going to have 70 grams of sugar. Okay, so just put 70 grams. Okay, a lot of our answers today, because we're working with scatter plots, they're going to have a label. Grams, calories, hours, okay, something like that. All right, so now part C, this is the question that's kind of getting at the big idea. It says, what tends to happen to the number of calories as the number of grams of sugar increases? So now you're trying to look for a pattern. Okay, what tends to happen to the number of calories as the grams of sugar increases? Kaylee? No? Not sure? Dave?
Both of the calories and sugar increase as the number gets higher.
So as the number of grams of sugar increases, the calories,
Increase or the other way too.
they increase as well. Yeah, that basically looks like the pattern. Okay. So let's just write that down. Let's see. Whoops. Put that there. All right, so what tends to happen is the number of calories, okay, as the gram of sugar increases, the number of calories also increases. Okay, can anybody think of another question they could have asked besides this? What's kind of another way you could ask this question? Maybe in like reverse. What could you say, Josh?
What happens when the number of calories to the sugar?
Okay, you could also look at it that way. You could say, as the calories increase, what happens to grams of sugar? Well, then you'd say grams of sugar also increases. Or what if I said to you, what happens to the calories as grams of sugar decreases? As the amount of sugar decreases, Ashley, what happens to the calories? Yeah, it also decreases. Okay? It's basically, it's the same question. You're just saying increase instead of decrease. Okay, so any question on example 1? All right, so this kind of problem, you don't have to make a scatter plot. They already give it to you. You basically just have to look at it. Okay, that's example 1. Now, this pattern, like if I was to draw a line, I might do it about like that. It's kind of in the middle of the points. Does anybody know what you call this pattern? I think Vanessa said earlier, it's like it's going up and to the right, but it has a special name. Yeah? That's the first word. It's actually 2 words. This is called a positive, yeah. Positive what? Not line, but it's called a correlation. Okay? Correlation means that there's a connection between 2 things. Okay? Like I might say to you, there's a correlation. I think that's, you know what you can do? Right on the bottom, just write this in right on the bottom below those 3 examples. Okay, you don't have to write the second sentence. Just write what I'm underlining. A correlation is a relationship between data sets. You already wrote the second sentence under that first bullet. Okay, I'm just going to go back for 1 second. You pretty much wrote that second sentence right here. Scatter plots are used to show patterns in data. You can use a scatter plot to describe the correlation in the data. Same thing. Right, so can anybody think of two things that have a correlation, like they're related to each other? Like grams of sugar and the calories in a drink. There's a relationship. You add more sugar, you get more calories. Anybody think of anything else that there's a relationship between two things? Yeah?
Like work and money,
Yeah, exactly. Can you explain what you mean by like working and money?
like how many hours you work, like, and then how much money you make for every hour that you work.
Yeah. So if you work at the kind of job where you get paid by the hour, then the more hours you work, the more money you make. So there's a relationship between money and hours. Okay, exactly. That's a correlation. Okay, and there's 3 different types of correlations. And I think I think we already hinted at the first one. Does anybody remember what I said the first one is called? Yeah, it's called a positive correlation, okay, which means as x goes up, y goes up. How about the next one? That's a negative correlation. Okay, I'm just going to abbreviate correlations, COR. And what do you think this last one is? Yeah, there's no correlation here. All right, so something that you wouldn't think would have a correlation, most likely, might be like the temperature out, or say how windy it is outside, and the grade you get on a test. You know, there probably isn't really much of a correlation between how fast the wind is blowing and the score you get on a test, right? So that kind of thing would probably have no correlation. Anybody think of a negative correlation? Okay, the smoothies, that was a positive correlation. Shannon's example of working and money, that was a positive correlation. How about a negative correlation? Where the more you do something, the other thing goes down. Instead of the more you do something, the other thing goes up. Yeah?
Like, like going shopping and money, like you're spending the money.
Okay, so maybe the more hours you spend shopping, the amount of money you have goes down, okay, on average. As the shopping time increases, the amount of money in your wallet decreases. Okay, so that could be a correlation. Yeah. All right, so there's some different examples. Does everybody have these 3? Positive correlation, negative, and no correlation? Okay. And did everybody add that sentence? A correlation is a relationship between data sets? Okay. So that's all a correlation is. It means there's a relationship. Okay, and if you look at your book, you just can look at this. You don't have to write this down. But a couple of you already noticed. You can think of a positive correlation as basically having a positive slope. It's just like positive slope. And the negative correlation, it's like negative slope. Okay, it goes down as you go to the right. Okay, so it's the same idea. All right. So before I even look at this, would you think that there is a correlation between how old somebody is and how many cars they've owned, necessarily?
No.
I mean, is it definitely a correlation? Like if you add more sugar, you definitely have more calories. There's no question. You can't add more sugar and somehow get less calories. But do you think that older people always have owned more cars than younger people?
Nope.
Maybe not, right? Somebody, maybe they've only had a couple cars all their life, or maybe if they don't drive or they take public transportation, they might not even have a car, right? So there might not necessarily be a connection between how old you are and how many cars you've owned. So how would you describe this one? Positive, negative, or no correlation? Yeah?
No correlation.
Yeah, I'd say there's no correlation there. At least with this set of data, it doesn't look like there's really a pattern. The dots are just kind of spread out everywhere. Okay, so no correlation. Okay, how about temperature and coat sales? Would you think that there could be a correlation with how warm or cold it is out and whether or not people are buying coats? Yeah. When are people probably more likely to buy coats? Yeah, when it's colder. So let's look at the data and see what it looks like. So I think our idea was pretty accurate. So now it looks like there's a pattern here. We just have to describe it. Positive correlation, negative correlation, or no correlation? Marissa? Yeah, that's a negative correlation. Now, can somebody explain to me what that means here? What does it mean that there's a negative correlation between temperature and buying coats? Kyle? Yeah, as you could say that a couple ways. As the temperature goes down, as it gets colder, the amount of coats bought go up. Or you could say as the temperature gets warmer, the amount of coats people buy go down. Okay? So that's what the negative correlation means in this case. Okay, so sometimes you'll have to explain that, like we just did. All right, let's look at the third one. Stopping distance of an automobile. All right, so this is going to have to do with how fast a car is going and how long it takes the car to stop when they put their brakes on. Do you think there's a connection between how fast you drive and how long it takes you to stop your car?
Yes.
Yeah. I would think there's a connection, so let's look at it. And here, this looks like a really almost a straight line. It's a little bit of a curve to it, but a little bit of a straight line. So what kind of correlation here? Yeah, it's a positive correlation. And can somebody explain what that means here? There's a positive correlation between how fast you drive and how long it takes to stop. But what does that mean? Yeah, so the faster that you're driving, the longer it's going to take to stop. Okay? Things like that. Okay, any questions on that one? Okay, so there's an example of a positive correlation, negative correlation, and a no correlation. Okay. Now, again, the book gave you the table, or they gave you the scatter plot. Okay, so you didn't have to make it. Let's take a look at this one. Just by looking at that table, really quick, like if I just put it up and take it away, can you tell what the correlation is? Just by looking at it that quick. Josh? No. Okay, if I just put the table up that quick, take it away, you can't tell. But if I put that picture up the same amount of time, could you see the correlation in the picture? Yeah, because it's a picture. It's a lot quicker. It's a lot easier to see it. So what we're going to do is we're going to turn that table into a scatter plot. Okay, what's a couple things that I need to do here if I want to make a scatter plot using this grid?
Label things.
Yeah, I've got to label things. Probably the best thing to start with is labeling my grid lines, okay? Because I don't have any labels. Do we know what's going to go on the x-axis? Yeah. What did they say to put on the x-axis? Yeah, the age of the car. Okay, so that's in years. Okay, so I'm assuming that's like a car that's 1 year old, 2 years old, 5 years old, and so on. So on the x-axis, put age and years. You don't have to put of a car, because when we put a title on this, we're going to say what we're talking about. So that's age measured in years. And what's on the y-axis? Value. Okay, so value, and how is value measured? It's measured in thousands. So this is like 24,000. Okay? 15,000. Okay? So put it off to the side, but leave a little bit of room so you can fill in some numbers. And there's one more thing I should label before I even put numbers. Yeah, so let's put a title. What do you think a good title would be?
Cars.
Well, what about cars? Common colors of cars.
Each age of car.
Yeah, car value over time, things like that. So I'm just going to put car value. We can put over time. And now, what's the highest age I have to go to? 8. Do I have enough grid lines to go from 0 to 8? Yep. So let's do that. We got 0, 1, 2, 3, 4, 5, 6, 7, just enough. 8. Now, what's the highest value I have to go up to? If I go by ones, do I have enough space to do that? No. I only have 1, 2, 3, 4, 5, 6, 7, 8 lines above the 0. So even if I go by 2s, that won't be enough. So we go by 5s. Could I go by 3s? Yeah, I think 3s would be just enough to fit it on this grid. So let's put 3, 6, 9, 12, 15, 18, 21, and 24 right at the top. So anytime you want to set up a scatter plot, that's the first thing you have to do. Label everything, and then set up your numbers. Okay, so now, take a few minutes, okay, and see if you can put down these 8 values as points. So find where the year is 1, and then find where the value is 24, and put a dot right there. Okay, so take a couple minutes and do that for all 8 points. And then we'll rock around and see if you guys see a pattern. All right, so I'm going to graph the points and see what I get. So I've got 1, 24. 2 looks like at about 21. If I get one that's not on a line, I'm just going to estimate it the best I can. Okay, 3 looks like it's about 19. So far it looks like a pattern, but I got to see if the rest of them make a pattern. 4, well, it should be right about there, 18. 5 is at 15. 6 is at 12. 7 looks like it would probably be right about there, maybe about 8. And 8 is 7,000. Oops, so no, it should be just above the 6. Okay, how many people had a scatter plot that looked kind of like that? Okay, good. So is it a perfect line? No, it's not perfect, but does it definitely look like there's a pattern? Yeah, what kind of correlation? Yeah, this is a negative correlation. So that's what the problem was asking you to do. Okay. Tell whether the data shows a positive, negative, or no correlation. All right, so what does that mean? There's a negative correlation between the value of a car and its age. So if you had to say that simply, what does that mean? What does that mean, that there's a negative correlation between the value of a car and its age? Yeah, Josh?
The older the age, the less value.
Yeah, basically exactly what he said. The older the car, the less value it has, in general. Okay, remember, this is just an average. Right. So any questions on that, making your own scatter plot? So on the test, this is how it would be set up. You'd have a grid, but you'd have to fill in the labels, the numbers, and then the dots. You'd have to do all that yourself. Okay, but you'll already have a grid, so you won't have to draw grid lines. All right, so the last thing we're going to look at, and this is how it's going to kind of tie in with what we were doing with lines and slope a little bit, is that, and did you have this on your sheet? Let's see. All right, you'll have the 4 steps in a second. But when a data shows patterns, okay, when there's a pattern, either a positive or a negative correlation, what we can do is we can model the data using a line. Okay? We can actually figure out what would be the equation of the line that looks something like this. If we can find the equation of that line, then that line basically is a good estimate for these points. Okay? Then I wouldn't even need the picture. I could just have an equation, and you could say, well, my car is, I don't know, 2.5 years old. Can you tell me what it's worth? Well, if I knew the equation of this line, I could figure that out. I just have to plug in a 2.5, and the formula would tell me how much the car is worth. Okay, so that's the last thing we're going to do, is try to figure out this line. In order to write the equation of a line, you need to know 2 things about it. Does anybody remember the 2 things you have to know? Yeah? Yep, you have to know the slope. Okay, that tells us how steep it is. And what's the other thing we need? Yeah, we need the y-intercept. Okay? In this case, you can't quite see it. It goes off the graph a little bit. But the y-intercept is where it crosses the y-axis. Okay, so those are the 2 things you have to figure out to find the equation of that line. All right, so when you draw a line of fit, this isn't really like an exact thing. Okay, you just kind of draw it the best you can. Basically so that it's pretty close to most of the data points. Okay, so like if I had something, let's just go back and look at this one. If you drew a line like this and said, oh, that's my line of fit, would you say that's a good line of fit? Yeah, not. It could be a little better. I would say something like that. It's probably better. It kind of goes right through the middle of the points a little bit better. Okay, so we just try to draw it the best we can. All right, so now under the steps, you've got 4 steps that says using a line of fit to model data. Okay, first step is you've got to make a scatter plot. Because maybe the data you're trying to make a line for, maybe there's no pattern. And if there's no pattern, then you're not going to make a line. Okay, there has to be a pattern. Okay, so step 1, make a scatter plot. Okay, you guys just did that in the last example. Okay, step 2, decide whether or not your scatter plot, the points look like they're in a straight line or close. if you had a scatter plot that looked like this, would that be a good scatter plot to try to use a line for it? If the points were like that? No, because they're all spaced out. All right? There's no pattern to them. How about this? Would that be something that you would use a line for? Well, does it look like there's a pattern to it? Yeah, there's definitely a pattern, but to me it looks like it's more of a curve, not really a line. So sometimes you graph points and there's a pattern, but they don't make a line. Okay? How about something like this? That's definitely something you could use a line for. It's not perfect, but it's close. Okay, so we got to decide whether or not our scatter plot can be modeled with a line. Okay, step 3. Draw a line that's as close to the points as you can do. Okay, maybe about like that. And they give you a hint that you should have the same number of points above and below the line. So if I look at my line, looks like I've got 1, 2 above it, and I've got 1, 2, 3 below it. And I can't tell because I put my line, but there's a bunch of points that were right on it. 1, 2, 3, 4, 5. So that's pretty good. 5 points right on it. 2 above, and maybe 3 below, or something like that. If you did a line of fit and you did it like this, I'd say that's a little low. Okay, you have every point above it. You don't really have anything below it. Try to put that line right in the middle. Any questions on that step? It's basically it's like a guess. Okay, just do it the best you can. And like if you need to use your ID or if you need a ruler or something like that, we can use something like that. Okay, and the last step is to actually now take your line you just drew and write the equation of it. And as Vanessa said, there's 2 things you need to find. The slope and the y-intercept. Okay, now here's the last part that some people, they get kind of confused with. When you're finding the equation of this line, you don't actually have to pick points, original points. Right? I'm probably not going to use this point. It's way off the line. I'm probably not going to use this one. It's way off the line. What I'm probably going to do is just say, well, that's the end of the line. That's the other end. I'm just going to use those 2 points. Now, those dots in blue, were they original points that I had in black? I don't think so. If I move that line away, there was no black dot there. There was no black dot there. So what I'm saying is when you find the equation of this line, you don't have to just use the original points. You can use any point on this line. If you want to make one up right there, there wasn't one there, but that's fine. Make one up right there. Okay? Make another one up right there. You can make one up anywhere you want, as long as it's on the line. Doesn't have to be one of the original points. Okay, so any questions on that? That's what that second sentence is saying. You can make up any point you want. Just put it on the line somewhere. What I try to do is make up a point that's easy to work with. Okay? Try to make up a point that is as simple as possible. Right, and when we found equations of lines, what were the two formulas we used? Does anyone remember the name of one of the equations? Okay, so it used an intercept and slope intercept. So that's one way to do it. Okay, so when you're writing your equation of a line, slope intercept. That's the way we're going to do it. But does anybody remember the other way we did it? Point slope. You can use point slope if you want. I don't think I'm going to do it that way. I'm going to stick with slope intercept. Okay, but it depends on the problem. If it's easier to do point slope, maybe I will. Okay? If it's easier to do slope intercept, I'll probably do that. Whichever one is easier. That's how I'll do it. And can somebody tell me what's the formula for slope intercept? Starts out y equals mx plus b. And what's the m stand for? That's your slope. And b, y-intercept. So again, I think that's how I'm going to try to do it. Okay. Does everybody have the 4 steps? Okay. For the problem that we do, step 2 says decide whether the data can be modeled with a line. I'm going to pick points that work. Okay, I'm not going to pick ones you can't do. All right, so let's look at that last one. Okay, so it says the table shows weekly sales of a DVD and the number of weeks since its release. So in other words, when they released the DVD, how many copies of it sold right away at week 1, and then how many sales of the DVD at week 2. And what does it look like is happening the longer the DVD has been out? What happens to the sales? They what? Yeah, why do you think that happens? The longer the DVD's been out, they seem to make less money. How come? Why could that happen? Yeah, it might be less popular. People have already bought it. People maybe went to see it. It's not as new, so it doesn't make as much money. All right, so it says write an equation. Okay, so when I'm done, I want something like this. Y equals, and then I'm going to find my mx plus b. Okay, so write an equation that models DVD sales and the number of weeks since the DVD has been out. All right, so to write an equation, what's the first thing I have to do? Well, what am I writing an equation of? An equation of, well, what's the equation, what's the shape of it? And what shape is that when you draw it? Is it a circle? So look back at the steps. What are we trying to draw? We're trying to draw a, Shannon? We're trying to draw a line. Okay, we're trying to fit a line. So can I just go like this and say, oh, there's my line?
No.
No, what do I need to do? I can't just like draw a line like that. I got to do something first. I got to put the points on it. Okay, so take a second and try that on your own. Put these points on the graph. Do you guys already have the DVD sales graph? All right. So just take those points and see if you can copy them onto the grid. And then when you're done, take your ID. I think that's probably big enough. Yeah, take your ID and draw the line the best you can through the points. All right, so let me try to get the points on my scatter plot, and then we'll see if we can get a line. Okay, so at week 1, they sold about 19. But that's not $19. What is that? 19 million, right, 19 million. Okay, week 2, looks like it's at about 15. Week 3 drops down to 13. Okay, week 4 is about 11. Week 5 is 10. So far they kind of look like they're in a pretty straight line. Week 6 is about 8. Week 7, let's see, be right about there. And week 8 drops down to 5. Okay, do those look like they're pretty straight? Yeah, I think overall they look pretty good. So now let me put a line the best that I can. Right, do you think that my line looks pretty good? How many points are under my line? 3. 1, 2, 3. How many points are above my line? 3. That's what you want. And there's actually, 1, 2 right on it. So I would say that's a pretty good line. Right. So now I want to find the equation of that line. All right. Does anybody remind me, what are the 2 things I need to find? Slope and y-intercept. Okay. Does anybody see the, let's try writing. Does anybody see the y-intercept? Yeah, looks like this graph crosses at 20. Okay. Remind me again, what letter is the y-intercept? B. That's the B in this formula. Y equals mx plus b. So I've got B. What other letter do I need? M. That's my slope. Okay, what's the formula for slope? Shannon? Yep, y2 minus y1 over x2 minus x1. The only thing is you need 2 points. Okay, and let's make up a point that's easy to work with. Was that point that I just did in red, was that on the original graph? No. But is it on my line? Then it's okay to use it, as long as it's on my line. Who can tell me the coordinate of that point? 0, 20. Why do you think I picked that point? I mean, I could have picked a point anywhere that I wanted. Wow, what makes that point easy? It's on the line, but so is that point. Oh, it's like right on the axis. Gotcha. Yep. So that makes it a 0. Yep. It's right on the axis. I'm going to pick another point right there. Okay. What's the coordinates of that point? Well, 0, 0 would be over in the lower left. So I heard a couple. Yeah, I think it's about 10, 0. Right. So let's take these 2 coordinates. Let's call this one x. Just because I'm closer to it, I'm going to call this x1, y1, and that's x2, y2. Now I can use those 2 coordinates, and it's going to help me to get my slope. I'm going to fill into that formula. Okay, Marissa, what is y2? All right, so slope is 20 minus. What's y1? About Natalie? How much? 0. What's x2, Liam? 0?
20? Oh, no. Oh, yeah, 0.
And what about x1?
10?
10. Okay, so let's do that out and see what the slope is. How about Maggie? What's 20 minus 0? So we get 20 divided by 0 minus 10. How much is that? Negative 10. Right? 0 minus 10 is negative 10. And can I reduce that at all? Yeah, what does that reduce to?
2 over 1, negative.
Yeah, negative 2 over 1. And what's negative 2 over 1? This is negative 2. That's my slope. So using my slope and y-intercept, can somebody give me the final answer? Yeah.
Y equals negative 2x plus 20.
Perfect. Negative 2x plus 20. And what that negative 2 means is that every week that goes by, the sales are dropping $2 million. That's really what that negative 2 means. Okay? So every week that goes by, the sales from the DVD drops another $2 million. Will y ever be a negative number? Will sales ever come out negative? No. What's the lowest amount of sales they could have? 0. You can't go any lower than 0. All right, so everybody have that equation? All right, perfect. Okay, so couple reminders before I pass out the homework. Okay, brand new term. Okay, so if you get all your homework in on time, you get 2 bonus points on your final average. Okay, so everybody starts fresh with that right now. Last academic week before vacation. Thursday, that'll be our MCAS review question and review. The only thing that could change that is if we have some kind of snow or something like that. But even with snow, we'll still have a test on Friday.